Machine learning? It sounds like a term from the future, but Scikit-Learn makes it the present. This Python powerhouse takes the complexity of algorithms and transforms it into simple, accessible tools. Welcome to Day 6 of the 30 Days of Machine Learning series. If you're new here, don't worry. Just click the playlist link right here to catch up on the journey so far. And don't forget to hit that subscribe button so every new video from this series shows up in your feed. In this video, we're diving into the world of Scikit-Learn. This library is so vast and versatile, we could talk about it for hours, but don't worry. Today, we'll focus on the essentials. We'll explore some key terms, must-know functions, and important classes to build a solid foundation for your machine learning journey. So, whether you're building your very first model or brushing up on the basics, this video will give you exactly what you need to make Scikit-Learn your go-to tool for machine learning. Stick around, because by the end, you'll feel confident navigating this powerful library like a pro. The first aspect of the Scikit-Learn we will explore is the data. Scikit-Learn comes with some standard machine learning datasets, which means you're not required to download them from an external website or database. Let's use this knowledge to load our data into a pandas data frame, which is much easier to manipulate and analyze. Data exploration is not the main focus of this video, but it's an extremely important step in any data project. Data processing is a vital step in the machine learning workflow because data from the real world is messy. Let's standardize the features using Scikit-Learn's StandardScaler class. This will ensure the mean of each feature is approximately equal to 0. Before a machine learning model can make predictions, it must be trained on a set of data to learn an approximation function. There are several ways to split data into train and test sets, but Scikit-Learn has a built-in function to do this on our behalf called train, test, split. We'll use this function to split our data such that 70% is used to train the model, and 30% is used to evaluate the model's ability to generalize to unseen instances. Now let's build some models. Thanks to Scikit-Learn, building a machine learning model is extremely simple. We are going to build 3 models to predict the class of wine. This code uses each of these trained models to make predictions on a test dataset. The predictions for each model are stored in separate variables. Model evaluation is done to test how well the model generalizes to unseen instances. Scikit-Learn provides an array of classification and regression metrics to evaluate a trained model's performance. For our use case, we are going to use classification report. Here's how it looks in code. We've discussed some properties so far, but there are additional important properties in Scikit-Learn that might not directly continue from the previous code. However, they are essential for understanding and working with the library effectively. Here is a simple example where we fit a random forest classifier to some very basic data. Once the estimator is fitted, it can be used for predicting target values of new data. The pipeline offers the same API as a regular estimator. It can be fitted and used for prediction with fit and predict. As we will see later, using a pipeline will also prevent you from data leakage. In this example, we load the iris dataset, split it into train and test sets, and compute the accuracy score of a pipeline on the test data. The generalization power of an estimator often critically depends on a few parameters. For example, a random forest regressor has a n estimators parameter that determines the number of trees in the forest, and a max depth parameter that determines the maximum depth of each tree. Scikit-Learn provides tools to automatically find the best parameter combinations. We randomly search over the parameter space of a random forest with a randomized search CV object. When the search is over, the randomized search CV behaves as a random forest regressor that has been fitted with the best set of parameters. And that's a wrap on our introduction to Scikit-Learn. We've covered the essentials, but this is just the beginning. For a complete guide, check the link in the description. We're exploring all key topics in machine learning in this series, so don't forget to subscribe. Up next is an exciting video on supervised learning. Click the link on the screen to watch now. See you there.